3 dimensions. We are adding a z-axis. Now, I have given you some graph paper so that you can practice all of this, okay? Right now, all you see is one of the 8 octants. Yes, there are octants instead of quadrants because we now have a 3rd dimension, okay? But what I want you to see is that the x-axis is going to shoot out kind of towards you. The y-axis will shoot off kind of to the right and left from that perspective. So the xy plane is what we can think of as like the ground. The xy plane is parallel to the ground. Okay? And then our z-axis is going to shoot up out of that. Okay, so we still have the origin 0, 0, 0, where the x, y, and z axis all meet. Okay, now I'm going to give you another visualization here soon, but this is what I want you to think about. So we have 3 planes that are colliding to make our 3-dimensional space, is what we call it. So we have 2-dimensional planes and 3-dimensional space. So if you want to visualize you being in free space, because we are, right? The ground is like the XY plane, right? This wall right here would be like the XZ plane, and then the wall where my board is would be the YZ plane, and we would all be living in the 1st octave. Okay? So if you want to imagine, like, the floor along here is the y-axis, the floor along here is the x-axis, and then the corner shooting up is the z-axis. Okay? I know it's not always ideal to visualize 3 dimensions on a 2D plane, but we're going to do our best. Okay? And that's why I want to give you some visuals in the room. All right? Now, here is the full effect. Okay? You can see, oh, it's even the same colors as the one up above. That was a coincidence because I just found this image. So the green is the XY plane. The reddish color is the XZ plane. And then the blue would be the ZY plane. Okay, adjust your eyes. But where X, Y, and Z are all positive, that is the 1st octave. Okay, now there's 8 octants because those 3 planes divide up our space into 8 different sections. Okay, and this is what we're going to mainly work on today. How to plot points and where they live. Okay, and then we'll also talk about distance. So the 1st through 4th octants, they are all where Z is positive. And we're still going to go in that counterclockwise fashion. So octants 1 through 4, we start here where X, Y, and Z are all positive, and then we work counterclockwise. So 1, 2, 3, 4. Okay. So right here would be octant 2, up here octant 3, and in this space here, octant 4. Okay, so those would be 1 through 4. Then octants 5 through 6 are just below that. So below octant 1 is octant 5, and then octant 6 down here, octant 7, and then octant 8 is below octant 4. Okay, so trying to think if I have anything that would be easy to see here. Okay. Here's the XY plane, here is the Z-axis, right? So octants 1, 2, 3, and 4, and then down below octants 5, 6, 7, 8. Okay? Am I holding this at an angle where you can see that? Yes. Okay, so I need to go through that again. Okay, good. I'm going to do it one more time. Okay, so above the XY plane where Z is positive, 1, back 2, 3, up 4, and then just below, 5, back 6, 7, up 8. All right, now we are going to plot some points. What I want you to notice with this right here, notice how they like make a rectangle and then like make it travel up. Okay, that's what we're gonna do. I want you to basically draw a path for your coordinate, because without those red lines, you just have a dot floating. Okay, we have really no perspective as to where it's floating. You know, if you draw a cube, you can see that cube a few different ways. You could see this as a front face, or you could see this as a front face, right? Same thing if we just draw a coordinate somewhere. We have to actually like map out its path so we know where it is. Okay? So this is my suggestion. I would not use up all 3 of your graphs during notes, because you will want a couple, or at least one graph for your homework, because you're going to have to practice graphing in your homework. So I would either use 2 in your notes and 1 for your homework, or vice versa. Oh, yeah, sorry, you were. Here we go. Okay. So yours already has the axes drawn on. So just give me a moment. X comes out at you. So this is going to be our X coming out at you. Okay. So if I'll do this one in blue. If we wanted to plot 2, -3, 5, we're going to start in the XY plane. So X is 2, Y is -3. So X is 2, Y is -3. So I'm going to create this rectangle, because this is X is 2, this is Y is -3. -3 for Y, +2 for X. And then from that corner, we're going to move up 5 for our Z coordinate. So we're just going to count 1, 2, 3, 4, 5. And then we'll mark it so we can see the path of which that travels. Okay. All right, Gabe, the master of the octants. Which octants is this in? Octant 4. Do you agree with Gabe? It is in octant 4. Okay. So we're above the XY plane. Z is positive, which means it has to be 1, 2, 3, or 4. Okay, and right here, this starts in 1, and we rotate counterclockwise. So 1, 2, 3, 4. It is sitting above the XY plane in octant 4. All right. Yes. I mean, I think that's something that if you want to see that pattern, I'll let you figure that out. Otherwise, I don't want you to sit there and memorize signs. I want you to visualize what's happening. Okay. So then this next coordinate is negative 2, 6, 2. All right, so x is negative 2, which means on the x-axis we have to go backwards. Y is a positive 6. So then we'll create that rectangle. And then from there, our z is 2. So from that corner, we'll go up 2. Kelsey, what do you think about the octant? Kelsey thinks it's octant 2. Do you agree with her? Yes, it is an octant 2. Okay, when x turns to negative, but the others are positive, Gabe, it would be an octant 2. What? Maybe the angle's probably different. No, angle's not different.
You have
They're
more
wider.
squares is what he's asking. We have more length on the x and y.
Oh, yes, I have more grids than you. Okay. Now, Gabe, if it helps, like octants 1, 2, 3, and 4 are going to have the same x, y signs as quadrants 1, 2, 3, and 4. You see what I mean there? All right. Oh, next two. I really should get these drawn in ahead of time. So Z. Oh. Okay. Well, it's not beautiful, but we're gonna. No, I can't. Okay. Good. 300. Where does that lie? Okay. So it's literally on the x-axis. It is sitting in the xy plane. It is also sitting in the. That's not the only plane that it's in. What other plane does it lie in? It also is in the xz plane. Okay? But I would describe this as on the x-axis. Okay? We can't say that it's in an octant because it's on an axis. But we can say that it lies on the x-axis. Okay? Now, what about this one? 404. Okay, so the x-coordinate is 4. The y-coordinate is 0. So from 4, 0, we will have to move up 1, 2, 3, 4. Okay, do you see how important it is for you to put that dotted line? Okay, without that dotted line, it looks like this is on the y-axis, but it is not. Does this coordinate lie in an octant? It does not. It's lying in between two octants. So if it's not in an octant, it's either going to be in a plane or on an axis. Okay? So what plane would this lie in? So this is lying in the xz plane because we don't have a y coordinate, essentially. Okay. If your x coordinate is 0, you would probably be in the yz plane. We're going to get some practice at recognizing points, but are there any questions on how to plot those? Okay, so then let's talk about distance. The distance formula for 3 dimensions does not look much different than that in 2 dimensions. All we do is add in a z minus z squared underneath the radical. Okay? You do not need to write this down, but I want to show you why this formula works the way that it does. Okay? So, I need 2 people up here to hold these 2 balls. Thank you. So you hold yours up high. You just hold it right here. Okay? So these 2 gals are in free space, and those balls are the coordinates that we're finding the distance between. Okay? So what we can do is I can plot a 3rd point directly below Amanda's coordinate, to where the z coordinate is the only thing that is changing. The x, y stay the same. And I can plot it so that the z coordinate is the same from Kelsey's coordinate. Okay? And no matter where they are, okay, I can do that. I can find a point to where the z doesn't change, and from here to here, only the z changes. Okay? Thank you for your demonstration. So when I do that, here's that coordinate right here. Ultimately, we want to know the distance between those 2 points. Now, from here to here, this would be the coordinates x2, y2, z1. The x and y's are the same as this one, right? But the z would be the same as this over here. And what we create is a right triangle. Okay? So, do we know how to find this distance right here? 2 points in a plane. We know how to find that distance, right? If we wanted this distance right here, 2 points that lie in the same plane, we would say the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay? That's what we would do for that distance. What about that distance right there? The only thing that has changed is the height. So how do we find the distance between 2 points of different heights? If my husband is 6'3" and I am 5'2", what's the difference in our heights? Okay, all we have to do is subtract, right? So, we have a right triangle. We know the Pythagorean theorem will satisfy a right triangle. So, leg squared plus leg squared equals distance squared, or hypotenuse squared. Right? Those cancel out. If we solve for D, then our distance formula is just this. So it is essentially the three-dimensional Pythagorean theorem. Okay? We're still using Pythagorean theorem to get that distance formula. Okay? Are you okay, Gabe? No, you're not okay? Write down these two coordinates, please. We have the coordinate 419 and 216. Both of these coordinates lie in octant number 1. Well, we set it up. I know it's like seconds away from it being 12:25. So our distance, does it matter which coordinate you take first? It does not, okay? So it can be 4 minus 2 squared or 2 minus 4 squared. It doesn't matter. Minus 2, the quantity squared. 1 minus 1, the quantity squared. 9 minus 6, the quantity squared. So our distance, the whopping radical 13. Okay. When you get back from lunch, we'll do an activity.
Yeah,